Alright guys, I'm going to show you my Minecraft 360 server. I've got a lot of stuff here. Where to start? When I was learning Minecraft logic, I made this, which is just a sample of different logic gates. That way whenever I built anything else, I could just refer back to this. I guess I'll show you my timer. It uses just standard clock. I enable it. It goes through a shift register back here that shifts 1 bit at a time. That goes through a decoder to a 7-segment display and it counts up. Once it reaches 9, it ticks over to the next shift register, like counters usually do. There's a little bit of delay in there, but it works fine. Then I got a reset right here. That resets everything back to 0. I've got a T flip-flop counter that I can hook up to a clock. This counts up to 255, I believe. Yeah, that's 8 bits. 8-bit system. This is a mine track derailer, or a switch point that I made for my friend's world. If I take a minecart, you can choose where you want to go. Like this went to Matt's house. No, this is Matt's house. You can go to my house or my friend's house, or you can switch it. Switch it. Let's see if it takes us there. And it does. Another 4-bit T flip-flop counter. Here's the brains of the circuit for that circuit. After I built this, another friend joined, and I had to do 4 inputs, where just one button changes 2 switch rails. That's what those lamps are. And any of these will switch it. Just some messing around back here. Another counter. Don't know why I have so many counters. This is probably my favorite counter because I think it's this line. Yeah. This counts up to 15 as a 4-bit counter, and if you flip this, it resets it to 0. This is what I was going to use for my display for the counting system, but then I would have to decode the outputs, which that was too much circuitry for me to do without World Edit. These are just simple projects. I can't remember what all of them are. Shift register. Input a bit. Enable the clock. It just shifts any bit that you want down the line. This is my starting project on RAM, which I've got 16 registers over here. Got 2 registers over here, then 4 over here. I think this is a 1 byte system, yeah. You can input 2 numbers, it will save those numbers. And you can switch between them. That's what all this circuitry does. And then I just doubled it, and then I doubled it again. So this one can store 4 numbers. This one can store, actually I didn't double it, this one can store 15 or 16, 16 different numbers. And I've got a 4-bit counter, 2 flip-flop counter down here. And this is one of the decoding circuits I was talking about. That just goes to the enable output on each register. This guy I hooked up to a binary, it's a binary to BDC decoder. That's what this circuitry is, to a 7-segment display. So it shows up in binary and in decimal, or actually BDC decimal. Set 10 in there. This will read A. If it doesn't glitch, and it does glitch. That's redstone in 360, it always glitches out. Like here's an example. Don't know why it does that this version. That's why I stopped using displays. Just went straight to binary. This is a little game that I came up with. When the switches on both sides match, the lights light up. There's 16 different possibilities. It just uses the decoders and AND gates to the output. Simple stuff. Here is a RAM that I used in my PC calculator that I'll be showing later on. I can't remember where this came from, but I'll probably do a tutorial on how to build it. Then over here is my starting of a calculator before I switch to PC. This can add and subtract different numbers. Right now we're adding, so you look at the bottom display and that's 6. And if I flip this, you look at the top number. Here's the other register. Let me change it to day so you can see everything. Do 6 plus 4 equals 10. If I come over here and subtract it, equals 2, you omit this carry out. I built this using my book from digital class in college. You just invert the one of the registers. And just invert one of the registers and then invert the, where's my inverter? Invert the output to get a subtractor out of an adder. Here's a full adder that I made using standard gates. This is a multiplexer system I was testing out. This is a German adder. Is this adder? No, this is RAM that I found online. What I like about it is it's solid state, but it's a little bit bigger than my RAM. Here's my RAM. Get your enable, saves it to a D loop. Then you can output it, or you can reset it. Here's some instant wire I was working with. I haven't messed with this instant wiring forever. Don't know why that's... There we go. Now it should be instant. Yep. Here's a two-way repeater. passes signal this way, and it can pass it the other way. Some more instant wire. I was testing how to build the brains or the computer for the circuitry inside of a tunnel. And this was the tunnel dimensions that I had to play with. So the instant wire is pretty compact in here. Another example of it. Uses 3 XOR gates and a T flip-flop. And it just counts. Doesn't matter what switch you use. I was testing instant wire with the gates. I had to destroy it because I was building this monstrous thing. I think that's pretty much it. Thanks for watching.